Welcome to the Crazy Hat Chemist. So here we are doing another video in atomic structure and electron configuration. So let's get moving. Bam! So today we're doing the electron configuration, orbital box diagram, and set of 4 quantum numbers for iron. That's atomic number 26. So again, iron Z of 26, that's an atomic number of 26. That means it has 26 protons and therefore 26 electrons, since this is a neutral element of iron. You have yourself a periodic table. That is critical to doing these electron configurations, orbital box diagrams. So pull out your periodic table, and I want you to write out the electron configuration for iron using the noble gas notation of iron. So you're going to find your periodic table and go to the right. On the far right hand side are all the noble gases. You're going to pick the noble gas that is prior to, has an atomic number that is less than 26. If the atomic number for that particular noble gas is greater than 26, you can't use that one, you must use the previous one. So here's the noble gas notation for iron. Okay, so it is argon, and it must be brackets and not parentheses. That is 4s2 3d6. So yes, that is a 3d. So you need to look at my previous videos that delineate the period number corresponding to the s and p orbitals, and then the d's are 1 less than the period, and the f's are 2 less than the period or 1 less than the d's. So that is correct, that is a 3d. There are many students that get that as a 4d, and that is incorrect. Okay, so how many valence electrons are there in iron? So we're going to look at this and say, what is the largest principal quantum number? Only s and p orbitals, and add up all the s and p orbitals of the largest principal quantum number. So is it a 3 or is it a 4? You could be looking at 2s and 1s also, but I don't have the 2s or 1s. Those are all within the argon core. Okay, so I am only looking at the largest principal quantum number, which is a 4 in this case. So, and is there a 4s and a 4p? No, there's just a 4s. So how many electrons are in the 4s orbital? 2. So why do we have 2 valence electrons for iron? Because it's 4s2. Okay, now from here we're going to do the electron. So we got the electron configuration. We're going to write out the orbital box diagram. So here's the orbital box diagram. Now, just like with the electron configuration, you can use the noble gas notation. You can also use the noble gas notation for the orbital box diagram as well. So I'm writing it just like what I wrote before. So the reason that I write out the electron configuration and then the orbital box diagram, I have found out over the years that students find it much easier to do such. Now, you can go directly from the element to the orbital box diagram, but I find that most students find that it's easier to do the electron configuration from the periodic table, then from the electron configuration do the orbital box diagram. So I've got my orbital box diagram labeled correctly with the correct number of boxes. I hope you should see that the argon is in brackets. The 4s orbital is a single box. The 3d set of orbitals is 5 boxes in total. Okay, so every time you have a D subshell, you are going to have 5 boxes in total. Now, I'm going to place the electrons in the correct order in which they are placed in this particular element of iron. So here we go. 1, 2. Okay, so it's up, then down. Okay, and now the next set is all in the 3Ds, and I need to put 6 in there. And again, you need to follow the order in which they are placed. So that is up, then in the next box, 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 up. I know I repeated myself, but I do understand that. So all of these are parallel spins filled entirely. This is the maximum multiplicity Hund's rule right there being applied. Now, I still have one more electron to place, and that is being placed back, filling from the original orbital in this subshell, which is this first box on the left. Now I'm done. So now the question is this paramagnetic or diamagnetic? Paramagnetism has unpaired electrons. Do you have any unpaired electrons in iron? Most certainly you do. You have 4 unpaired electrons in iron. And so therefore this is paramagnetic. It's also a ferromagnet also, but that's a whole entirely different story. Okay, now I'm going to circle a random electron. Here it is. It's not the last electron, so I can't just look at the periodic table to determine the set of 4 quantum numbers. to represent that circled blue electron. So I'm going to have to go with the information that is given in this orbital box diagram to write out the set of 4 quantum numbers for that particular electron. So I want you to pause the video and I want you to try to do it yourself. So here we go. What's the n value? It's in a 3D. Okay, so therefore the n is a 3. Okay, what's the L value? It's a d-type orbital. So the L value of a d-type orbital is a 2. What's the m sub L value? So what you have to do is label all the boxes in the 3D, with the middle box being 0. To the right of the 0 is a 1 and a 2. To the left of the 0 is a -1 and a -2. What box is it in? M sub L of -2. And is that up, heaven facing, or down, hell facing arrow? And that it's up, so therefore it's a positive 1/2. So that's why I get all these set of quantum numbers right there. That's n of 3, L of 2, m sub L of -2, and m sub S of positive 1/2. Hopefully that worked out well for you. If it didn't, make sure you rewind this video and watch it again. Okay? I am the crazy hat chemist. I got a crazy hat on because I'm a cowboy today. Alright, so give me a thumbs up if you like that video. Please subscribe to my YouTube channel, and I will see you next time for more cool chemistry videos.